Okay, so I'll just go ahead and start. Rain is falling a bit loudly here, so I don't know how clear you guys can hear me, right? If you can, just ask me and I'll speak up a little bit more. It's not too clear. All right, so I want to cover Multisim today, so I'll just go over the basic introduction. I'll record the class, I'll put it up so that after you guys finish downloading it, maybe during class or after class, then you can look back at the video and go over the things again and ask many questions you might have in our next class. All right, so this is Multisim. After you finish installing it, right, you should also download the activator, which would look something like this. And then you just run that as an administrator, right? And then here you'll select from the different products that you have installed. It'll be 14.1, I think, and then you just click activate, and that's it, right? And you activate your Multisim. Okay, good. So after you finish that, then you can open it. And this is just the general Multisim layout. It's similar to any other Spice software that you might have. Maybe you have OrCAD Capture. My OrCAD Capture isn't working at the moment. Or maybe you have Light Spice or any other kind of Spice/P-Spice software going on. It'll just be here, right? The schematic window, which is where you drag and drop your electronic components, right? These Spice simulation softwares is specifically for like electronic engineering. So that we can drag and drop components and do some simulations before we actually go about doing electronic designs, right? Right, and like any other software, you can open new projects. In this case, it's not script files or anything like that, but you can just go ahead and click new to open up a new Multisim project or a new Multisim design, right? And that's pretty much it. Here we have like the components bar here. And here is just like some scope bars where we can have different things like multimeters, the watt meter, oscilloscope, function generators, anything that you would normally find in an electrical or electronics lab, right? And then you can just start dragging and drop components. It's pretty simple. So let me just make a simple circuit to start. So whether it's Multisim or OrCAD, you'll come up here, they'll have a place tab where you can place a particular component. So you click place, you click component. Okay, and then in here, you have access to all the different kind of electronic components you might want. They're grouped up in different groups like sources, where you can have AC power sources, current sources, things that you might want to simulate, right? Some basic stuff like resistors, capacitors, inductors, and of course, all sorts of different size resistors and capacitors and stuff, whether it's 1K or 1.69K. You can also do rated virtual resistors, right? Where you can adjust the value to any value you want, right? But it's best to just stick with the manufactured ones because these are the values that you'll most likely find when you want to go outside and buy these kind of components, right? Okay, so someone's asking if you have another Spice software, you can use it as well. It's just some things will be a bit different, all right? Multisim has a good set of features. I think OrCAD as well has a good set of features, but if you have another Spice software already installed on the computer, you can open it up and try follow along. Of course, some things might be different, but the basic layout should be the same and how you do things should be pretty much the same, all right? Good. Okay, good. So alternatively, instead of coming here, place and click component, you can just right click and click place component, okay? And you can place probe, which I'll talk a little bit about later, but essentially a probe is just a point in a circuit where you might want to measure the voltage and have the voltage being displayed while you're doing your own simulation. So you can alternatively just right click and click place component, right? So let's just build a simple resistor circuit, all right? Let's do a 2K resistor, right? Just type 2K. Click OK. And you can drag that resistor around. It's attached to the cursor. So you just press, you click where you want to drop it, right? So usually the layout, let me not put it there. The layout is limited to how you want to set it, right? You can obviously come in options, right? Sheet properties, and toggle different things on and off, how the different components are, right? The color. If you want like a white background, a black background, something like that, or like a black and white background or whatever. I usually just leave it default with the white background. All right, and then you can click whether or not you want the grid, which it is like little grid lines being shown or not. I usually just keep everything on default. You can play around with it if you want, right? Good. So back to doing that simple resistor circuit, right? 2K resistor attached here. So you go ahead and place that, right? Then maybe two 1K resistors. Right, so here, now you can press Control R to rotate the component, right? So you set up here, and then I want another one here. So press Control R again, rotating the component to put there. Alternatively, you can place the component, right? And then right click and click rotate clockwise or rotate anti-clockwise to rotate it to the direction you want or the orientation you want, right? So now this is just a simple resistor circuit we're creating. So back to place, or you can right click place, right? Place component. It's one of basic sources, right? A simple DC power source. DC power source, should find here, right? You can leave it as default 12 volts. If you want to edit anything, you just double click on it, right? And the DC power values, you can change everything that you might want from there, right? So you can change that from 12 volts. Same thing with your resistors, just double click on them. Then you can change the values. It's nothing too fancy, right? Right, now additional spice simulation parameters you might want to change. You might want to set temperature that this thing is operating on, right? You might want to set a particular tolerance and different things like that. Because, you know, certain resistors, like with a number of bands at the end, might have certain kind of tolerance. You can go ahead and put that tolerance in to simulation to cater for all the different variables if you want. But for now, we don't want to do that. All right, let's just keep it simple. All right, so we have a 12 volt voltage source, we have a 3 resistors. All right, we can just go ahead and connect up, right? So after hovering on the end of one of these devices, the cursor kind of changed from being this to this, right? So you just go ahead and attach that to the resistor and you just create your circuit. Right? Okay. And then here, we want to kind of connect up to here, but we don't want it so low. We kind of want a little bit space. So we can come down, we can click down at any part of the grid you want, and then drag it across and line it up, and then come back and attach this one. It's pretty simple. And after installing the software, you guys will get a hang of it, right? And you can play around and practice drawing all sorts of simple circuits, right? Now, after this, we can just simply click play, right? And it'll simulate the circuit. Now, the circuit doesn't really do anything. All it does is 12 volts, and it uses that to power these resistors, right? Or transmit current through these resistors, right? Which is nothing too fancy. Now, we can come over here to this bar, which has all of our multimeters and stuff, and we can drag a multimeter out, right? Drag a multimeter out, and we can connect it up and measure the different voltages that we want. Maybe we want to know what's the voltage across this resistor here, right? So we can go ahead and do that. Additionally, I want to just place a ground. I want to place a ground in my circuit because you should always ground your circuit, right? So I want to place a ground in my circuit, run it, and then click on this multimeter. And we see on this multimeter that the voltage across this resistor is 2.4, which makes sense if you want to work out the math, right? Let me zoom in as well, zoom in. Yeah. zoom into my circuit, right? Yeah. So let's just work the math out really quick. Shouldn't take long. Right, so we have a 12-volt source coming here. And into that we have a 2K resistor. Let me just verify that, 2K. And then two 1K resistors, right? 1K here, 1K here. And let's go back this way, right? Now, since we're taking the voltage across here and here, we can kind of lump these two resistors together, right? So you know, two resistors in parallel, we do the calculations for that. This will be 2K. And these here, we can just lump them together and make them one, right? Since it's two even resistors, we already know that that's about 500 ohms, okay? And then measuring the voltage across this, right? We know this is 500 ohms because we multiply the two and then add them up, right? And then we just find the parallel resistance there. We should know it's 500 ohms, right? Now from this, we just do basic voltage divider calculations, which would be 2,500 ohms divided by 500 times the 12 volts, right? So we just run that in just to verify that a multisim works, hopefully, right? So 12 times 500 divided by 2,500 is 1/5, which is 0.2 times 0.2, right? And that's 2.4. So multisim works. So instead of going through all the trouble of doing all this calculation, you can just draw up this circuit and measure the voltage, right? The same way you would do in a lab. And you don't have to worry about wiring something wrong and accidentally blowing a capacitor or something like that. So simulation can make your life easy, right? And you can use a multimeter. You guys know what multimeters are, and you can measure resistance and current, and you can do AC and DC current if you want as well, right? That's your multimeter. And if you're doing all sorts of different kind of analysis, right? Here's your wattmeter, your oscilloscope, your function generator, things like that, right? Now, the thing is, when simulating these things, we don't just want like a regular simulation running the circuit and measuring everything. Sometimes you might want to do a little bit more advanced kind of simulation, right? So you just come here, simulate, right? Click analysis and simulation here. And then from here, you can do all different types of simulation, right? We can do DC operating point, AC sweep, some transient simulation, DC sweep, right? Monte Carlo, some simulation with noise input into the system. We can do a sweep for different operating temperatures, right? Right? What's also different stuff, even for your analysis eventually, right? So let's just start with a simple one. This here was just the interactive simulation, which simulates the circuit for a certain amount of time. So the same way like in MATLAB, we would run the circuit for like 10 seconds or something like that, right? We would run the circuit some like 10 seconds. This here, you can run the circuit for how much ever seconds you want. And you know 1 plus 1 times e to the plus 30 is just the same as 1 times 10 to the plus 30, right? Just 1 with 30 0. So the default for multisim is just running the program for a really long time. Now, you can set a certain amount of time where you want to run the program for, right? To just reduce computational strain on your computer, and you can do the initial steps and max time step to increase the resolution, improve the accuracy, right? However, the simulation time will increase depending on how complicated the circuit is, how fast your computer is, and things like that, right? So you can adjust all those parameters here if you want that, doing that, right? Now, let's start off with a simple DC operating point, DC bias point. Sometimes it's called in other SPICE software, right? So DC bias point. And here, we can just pick out which values we want from particular points. Like for example, what is current through V1? So V1 in a circuit over here refers to the voltage source 1, right? R1 refers to the resistor 1, R2 resistor 2, and R3 resistor 3. And you see Multisim kind of labels everything for us as we go along as well, right? So we can say, okay, let's say we want the current in V1, we can go ahead and add that. Let's say we want the voltage at node 1 and the voltage at node 2. Okay. So the first one is the current through V1, and this is the voltage at node 1 and at node 2. And then we can do the current through the individual resistors. Let's just do the current through R1 and the current through R2. Okay. Then from here, we can go ahead and click run. And what it does, it pops up this window for us. And in this window, we just have all the different kinds of voltages, right? So first, we know the V at node 1. So maybe we should just display the nodes first. So to display the nodes, this here we know is node 1 and node 2, but you can configure Multisim to display the nodes for you as well. So you just come here, show all, and then you should get the nodes being displayed. So node 1, node 2. So when we refer to voltage at node 1, is this point with reference to ground, and voltage at node 2, this point with reference to ground. So you have a kind of a better idea what we're talking about. Okay, good. So from here, we see the voltage at node 1 is 12 volts here, which is the voltage across here, right? Which makes sense, right? This should be 12 volts. There aren't any voltage drops as yet. We already measured this part, the voltage at node 2 is 2.4, which makes sense because we did our little calculations and stuff, right? So we know that's right. So instead of doing that calculations, you can just do a simple DC operating point analysis, which picks out voltages or currents or powers across the different components we might want, right? Also, we have the current coming out V1 as being minus 4.8 milliamps, right? This little M here stands for milliamps, right? And the current through R1 is 4.8 milliamps, right? So this is a minus sign because it's leaving the voltage source. And this here is being powered, so it's 4.8 milliamps, right? As you remember, power is gonna come, current is gonna come, flow through here, and then here it's gonna split up. Because these two values are the same, these two resistors are the same, right? That current is gonna be split evenly. So it's like the 4.8 milliamps being divided into 2 across R2 and R3. So this R2 value is good as well. So it doesn't matter how complicated the circuit is, right? You can just draw it up, drop all these symbols, all your different resistors in, if you have capacitors and stuff in, and then you can do a point analysis, or you can just simulate and then drag out your voltmeter and stuff and just start measuring values, all right? So that's just the basic introduction to it. Do you guys have any questions so far on just using the software?
Nah, seems simple enough so far.
Yeah, so far it's simple. So what I really need from you guys is for you guys to download and install the software, all right? So anyone else has a question? No. All right, so after you guys download and install software for homework, right? This is what I want you guys to do. I just want you guys to do a simple circuit. You can add more resistors if you want. You can play around with adding more components, right? You can come in here, like all sorts of different components that you can think about, right? Any particular component you might want, right? You can stick to the basics. You can add in transistors. You can do some sort of small amplifier, a rectifier circuit, something that you know, right? Especially if you're an electrical engineer, you did your electronics course and stuff, you got some circuits in mind that you might want to simulate, right? So they're diodes, transistors and stuff. You can simulate and make sure they're working, right? And play around with the values and see how those values affect the circuit, things like that, right? All right, good. So now there are lots of different types of analysis, right? So slowly throughout the course of this month, we only have 1 month more for this semester, right? I think the last day for classes is 9th, so we'll have like about 5 classes on this, and we're slowly going to move through all the different types of analysis you can do with Multisim and the other SPICE software, right? So we started with the most simple one, right? Which is the interactive simulation, and that just says run this program for a certain amount of time. And from there, you can just pick out values and different things, right? Then we did the DC operating point. This is like particular operating points in the circuit. We want values like current, power, voltage, right? Okay. And you can go through all the different configurations if you want. Now, another thing you can do, let me put it back to interactive, right? Not anymore DC operating point. So it just runs, right? And then we can just add probes, right? Like place a probe. You know, place a voltage probe, put it right here. And what this does, when we simulate the circuit, it'll display that voltage there, right? So maybe you don't want to work so hard and go collect a multimeter and connect it up, or go into your components and find a voltmeter and connect it up, right? You just want a quick probe. So you can use probes, and that picks up certain things like the voltage, right? And it can specify whether that's AC or DC voltage. See, VDC is 2.4. But sometimes you might want different values, such as like RMS and peak to peak and the voltage frequency as well. So you can get those by just simply placing a probe, right? Again, there's nothing too hard about this software. The hard part of using the software is the actual circuit, knowing how the circuit works, right? Knowing how the components work, right? So that if something goes wrong, you know, say, okay, it's not the software that's wrong, it's my circuit that's wrong. Maybe I forgot to ground my circuit. I forgot to do something in my circuit, right? That's usually where the trouble comes in. But besides that, it's just dragging and dropping stuff, your components, and wiring up your circuits, right? You can also place a current source again, which is we can see the current. And go ahead and place that, and it's 4.8 milliamps, right? Now we can move this and put it through this line or this line, right? And it's 2.4 milliamps, right? And it just like that. Alternatively, you know, there are all sorts of different kinds of probes. There are power probes, digital probes as well. And there's this one, which is just a voltage and current source, voltage and current probe. So you might want to put that, and that will just give you the voltage and the current from one probe. So you just have everything stacked, that same 2.4 volts DC, and that 4.8 milliamps DC, right? It doesn't show the frequency or anything because it's not AC, right? And it doesn't really make sense to use an oscilloscope because these are just DC circuits, right? Okay, good. So that's just the basics. Maybe we can go through another type of analysis, right? We can try a DC sweep instead of the bias point. Since you guys don't have any questions, or maybe after installing the software, you might have a few questions here and there, all right? But let's just move on and try and do a DC sweep. So what a DC sweep is it's gonna essentially sweep across a range of a DC value, right? So let's say we have some voltage source, which is 12 volts. What the DC sweep will do, it'll essentially just pretend this is a variable voltage source and say, okay, start at some point, let's say 0 volts, and slowly increase its value up to 12 volts, right? And make note of all the different changes, all the different currents in the different resistors, right? All the different voltages, like the voltage across R1. Make note of that voltage and track it as we change the value from 0 volts to 12 volts, right? As we sweep and slowly increase this value, how does this voltage change? How does this current change, right? The current through R1, right? How does the current through R2 change? How does power change, right? The power coming out of the voltage source, V1. How do these different things change when we do that DC sweep? So DC sweep is another very simple analysis that we can do, right? After dragging and dropping components. So we can say the start value, start from value 0, and the stop value, well, let's increase that up a little bit to full to 12 volts, because it's 12 volt supply. And we can select the source we want here, right? So you can sweep that. And we can say increment, which is just the increment value, right? So we start at 0, then we'll go to 0.5, then 1.0, then 1.5, and so on and so forth, increasing the value, right? And then we can come over here to outputs, right? And then select what variables we want, whether or not we want the current through R1, the current through R2. Let's just see the current through R1. Let's go ahead and add that. And then let's just see the power through V1. Go ahead and add that, right? And then from there we just run, and we see the output is a bit different now. Now it's like a graph. Right? And of course we can adjust the graph. We can just come up here, show grid, all sorts of other things, right? We can set the preferences for these different lines, which you can do in your settings and whatnot, right? So we just come up here, show grid, so that we can measure things. Nice, all right? Good. So here on this bottom axis, we have from 0 volts to 12 volts. So as this voltage here changes, right, what are their corresponding power values, right? So you remember the power we measured was what was it, minus 4.8. Okay. Let me just rerun this. Okay, let me close it. I accidentally messed up the scale, so let me just do it. So let me just redo the simulation analyses. V1, the outputs. Let's just do one. Let's just do P. Go and add, run. So here we can see as we adjust the voltage from 0 to 12, the power slowly increases because the voltage increases, the load stays the same, right? So that power is going to increase. Right? And then you can slowly add all the other different parameters that you might worry about, like what's the power to R1, what's the power to R2, what's the current that's coming out, and how does that current relate to the power? And you can run that, and you can generate your graph as well. Okay. So the power is set up here in watts and the current is in amps. My recommendation is just plot one thing at a time so that here your units don't get messed up and don't look too weird, right? When you have different things going on. Right, yeah, but pretty much that's it for the two different types of analysis that you can do, right? Let's do a value that we know as an output. So just remove these two. Let's do the current, the voltage at node 2, which we know it's supposed to be 2.4 when it's 12 volts. So we can see how that voltage slowly ramps up from 0 volts. Right, this is voltage plotted with volts from 0 volts, slowly ramps up to that 2.4 value, right? Which is just on 2.5, that 2.4 value, which is the value measured with our voltmeter and the value we did a little calculations for as well. So yeah, that's all there is to Multisim. Of course, we'll do a bit more complicated examples. We'll do some more complicated analysis, but I think that's good enough for like just a brief introduction of it. All right. Any more questions you guys might have? Is anyone having trouble installing the software? Things like that. Anything?
I installing right now, but it's taking long to install.
Yeah. Well, it's It's a bit big. I don't remember how big it is exactly, but it's pretty big. I don't have it downloaded here, but it's pretty big, right? So that's what I want you guys to do. So if you already have it installed, go ahead, build this circuit. Do the two different types of simulations we talked about, right? The DC operating point and the DC sweep generating a graph. Okay, and then next class, we'll do some more of these different types of analysis, right? All right, good. And if you haven't downloaded the software, download it and then do this, right? Try this out, check it. So I guess that's it. All I can really do for now. Instead of trying to teach you guys a lot of stuff when you don't even have the software. Right? Yeah, and just do that, just play around with it, and we'll cover more stuff in the next class. Right? Good. So if you have it, you guys can go ahead and build that. Have any questions, let me know. I'll be right here. Yeah.
Mine taking a while to install.
Yeah. All right, so I'll just leave this up here for like a 15 minutes. So the persons that do have the software can go ahead and copy and play around with the circuit. And the persons that don't can just download the software and install it and then do this. Right?